students. I promised you some videos, so here's the first one based on the unit number 2 of the Del Mars book. And the video that's posted there for you to watch is pretty good. I left it in for a reason, but it does not explain this Ohm's law relationship the way that a typical first year electrician needs it explained. And so I decided to make this video to help you guys out. Hopefully, it goes well and I can keep it fairly quick. So, what you're seeing is a chart. When I was a first year student, it was actually a triangle. It works well as a circle or a triangle, either way. But this is our basic understanding of Ohm's law and how three key components of an electrical system or circuit come together and affect each other. All right. So the first thing I have to fix about the video is that we don't use V. We don't use V for volts. We use E. And E stands for, or it stands for electromotive force. So if you just break the word down, electromotive force, then it's electrons moving. And so we use E. Not sure why we use I for amps or current. In your textbook, it's not going to be referred to as amps as much as it's going to be referred to by current. And then we have resistance, which I will abbreviate. And the system we have, or the unit we have for that, is omega. But when we're doing the math, it's just simply R, which should make sense. Okay, so we have all three of these elements right on the chart. Okay, so that should be familiar. Now, the next thing I want to show you is how the chart actually works, because it actually represents math. Okay, so what we've got is, if you have to use your imagination, but if we have a divide symbol there and a time symbol there, we get these three equations. E divided by R equals, and it just equals the other one. We get E divided by I equals R, and we get I times R equals E. Okay, simple as that. I times R equals E. E divided by R equals I. E divided by I equals R. And that's how it works. Now, when I was first year student, I got to the point where I could memorize or I could remember these equations. And I did that until I realized that all of this stuff is in the Uglies book. And so there are some first or some second year teachers who do want you to have to be able to come up with those equations from memory, but I'm not going to be one of them. The math is hard enough as it is. And so anyway, that is a basic overview of our equations. And so let's apply some math to it. I have a fancy little calculator emulator that I'm going to use, but we're going to use some really simple numbers. So if all three of those values affect each other, just as soon as we get 2, we're able to do some math. So let's pick some too. Let's do a value for I of 0.5 amps. Okay, and then let's pick a value of R. Let's leave R blank. We're going to figure that out. Let's use a nice normal 120 volts for our E value. So what's our equation? We have amps, we have volts. So right here, our equation would be E divided by I to get our R. Okay, so let's go over here into the calculator. Maybe I've already got that in there. And let's do that. E, which is 120, divided by I, which is 0.5. Let's start that over. So you can see there is a certain buttons you can pick. That's an app. So we've got our 120 and we're going to divide that by 0.5. Those are the two values we have. And it's going to give us 240. And what is that 240? Well, that 240 is our resistance. So we can put 240 right there. And then our little upside down U symbol for ohms. Okay. So now we can actually double check all this. If we keep those values in our head and we go back to the calculator, we can check everything. So what was one we needed to check? 120 divided by 120 divided by 240, right? Volts divided by resistance, and we get our 0.5 for our amps. And then we also have our 240 times 0.5, enter, to give us our voltage, 120. Okay, so it really is as simple as that. The only difference is that for us to really get an understanding of how they affect each other, we also have to look at this big pie chart, right? And the only real difference is the addition of the P, right? So we have this whole section that's devoted to P, and for now, P is going to be watts. Okay, but do we have the other equations? So if we cross out all the equations that have P in them, what are we left with? We're going to cross all the P equations out. Do we have E divided by I? Yes, we do. Do we have E divided by R? All the way around. Yes, we do. And do we have I times R? Yes, we do. Right there. Okay, so even the very basic pie chart is going to, hopefully that's going to simplify it for you and you'll see how it works. So, all right. Let me briefly explain the power part of this so that I can get on to other videos for you. Keep forgetting that the faster you go, the more it erases. All right, so how do we use the power? If power is watts, simply I times E. So if we used our previous values of 0.5 times 120, then we get 60 watts. That's why it shows it. Okay, so if we have a 60 watt light bulb and we know what the resistance would be on that, it'd be 240. So right there, we use the Bauer chart to figure out watts. So if we picked a different formula, like let's do this complicated one right here. 120 squared divided by resistance will give us our watts. So what's our resistance? Let me erase that. Resistance is 240. And you already know what the watts is, right? It's 60 watts because I just did it. But what if I were to show you on the calculator? Let's clear. What did we have? 120 squared divided by 240. Enter, and there we go. Confirmation that it is in fact 160. So get back here. Yes. Okay. Like I said, hopefully these are a little entertaining. At least. All right. So, like I said, you have this chart on your uglies book. And you'll always have your uglies book available for testing and stuff. So if you have any questions about that, by all means, send them to me or join one of the live office hours. So thanks a lot.